Solving absolute value inequalities. So last time when we were talking, remember that if we had an and statement, that it was the intersection between two things. If it was an or statement, now does it always go like this? I'm going to do one. Does it always go that way? No, but for the most part, that's the difference between them. So today what we're going to do is we're going to take absolute values and we're going to use the compound inequalities. So for the real number A, this is a variable, the inequality, the absolute value of x is less than A, means that it's the distance from x and 0 is less than A. Every time I see that, I screw up. And I teach my kids less than. Okay, so basically what you're going to do is you're going to take what's in the absolute value right here and set it equal to the positive. And then take the absolute value and set it equal to the negative. So that's all you're doing. But so if I had the absolute value of x is less than 12, I would write x is less than 12 and x is greater than negative 12. And remember, I can rewrite that in one statement like this, because it's between those two numbers. Okay? So here we go. We're going to take this. You're going to write m plus 5 is less than 3, and m plus 5 is greater than negative 3. And solve. M is less than, oops, I almost wrote the wrong number, negative 2. M is greater than negative 8. Make sure you have your and in between, or you can write it as negative 8 is less than m, which is less than negative 2. Okay? I'm going to write this in set builder notation. M such that negative 8 is less than m, which is less than negative 2. And if I was going to write it in interval notation, negative 8 to negative 2, not including negative 8 and negative 2. And if I'm going to draw it on my number line, negative 8, negative 2, and all in between. Okay, so let's come to this one. So again, we do the exact same thing. I take 6m plus 12 less than 12, and 6m plus 12 is greater than negative 12. So this changed and this sign changed. So I subtract 12 from both sides. I get 6m is less than 0. Divide by 6 and get m is less than 0. And subtract 6m is greater than negative 24. Divide by 6 on both sides and get m is greater than negative 4. Or you can write negative 4 less than m, which is less than 0. Set builder notation. M, did it start off as m? Yes, it did. Such that, nope. Negative 4 is less than m, which is less than 0. And negative 4 to 0. I don't know why I was going to write a brace. So then I do an open dot and an open dot, and it's all the stuff in between. Okay, now I filled all of that stuff out up above. Okay, so now let's look at this. Okay, it says absolute value inequalities with no solution. Well, that's interesting. I, for some reason, have forgotten to put the absolute value on that. Okay, let's look over here. I want us to do this first. The solution for the absolute value of n minus 1 is less than negative 5 might be easier to understand if you think of the inequality in terms of distance. The inequality can be read as the distance between a number and 1 is less than negative 5. However, that would make the distance a negative number. Can you have distance as a negative number? No, you can't. So the answer is no, empty set. No solution. Okay. Awesome. So let's go to this down here. Now, that was less than. Now we're going to be dealing with greater than. And where did I write my little thing? Oh, I thought I had written it on here. Okay, so I think of this one as great or. Okay, so anytime you have greater than, it's going to be an or statement. So you're doing the same thing. You take off the absolute value, leave symbol alone. And then, oh, I messed this up. This should be now a less than. So you take off the absolute value, you change the inequality, and you change it from a positive to a negative. Okay, so we're doing the same thing except for it's an or statement. Okay, so this is going to be an or statement because this is greater. So I take the 2m minus 9 greater than 13, and then 2m minus 9, you change that to less than, and you make it negative 13. So it's either going to be above that number or below the negative of that number. So I add 9 to both sides. I get 2m is greater than 22. I divide by 2 on both sides. I get m is greater than 11. Or I add 9 to both sides. I get 2m is less than negative 4. I divide by 2 on both sides. I get m is less than negative 2. And I come down, this goes there. Okay, greater than 11, open dot, greater than 11. Go down to negative 2, which is here. And it's the stuff that's less than that. Okay, interval notation would be negative infinity up to negative 2. Union 11 up to positive infinity. And if I was doing set builder, it's m. I don't know why they're using m so much today. M is greater than 11, or m is less than negative 2. Okay, doing the same thing here. Okay, this is greater than or equal to, so that means it has an or statement. I take 4m minus 20 greater than or equal to 12, or 4m minus 20 is less than or equal to negative 12. I add 20 to both sides. I get 4m is greater than or equal to 32, divide by 4. M is greater than or equal to 8. Or I add 20 to both sides. I get 4m is less than or equal to 8. Divide by 4 on both sides. And get m is less than or equal to 2. So 2 and 8. So I'm not going to rewrite this, but that goes there. So interval notation, we're going from negative infinity to 2, or we're going from 8 to positive infinity. Set builder notation, m such that m is less than or equal to 2, or m is greater than or equal to 8. Okay. Let's look at this. It says overlapping case solution. Because the values of n, for n is greater than or equal to 1, and n is less than or equal to 11, overlap and they extend indefinitely in both directions, the solution is all real numbers. So let's take into account this right here. So n minus 6 is greater than or equal to negative 5, or n minus 6 is less than or equal to positive 5. So I add 6 to both sides. I get n is greater than or equal to 1, or add 6 to both sides, and n is less than or equal to 11. So remember, this is an or statement. That means we're going to take into account everything. So if I come here and I go greater than, and I'm going to do it in a different color. Here's 11, and I come here and I go in this direction. Because that's an or statement, we take all of the answers. So it overlaps. So what is the solution set? All real numbers. Actually, that's not set builder, sorry. This would go from negative infinity to positive infinity. Interval notation, negative infinity to positive infinity.